A rod made of glass, refractive index 1.5, and cross section and square cross section is bent into a shape of a shape shown in the figure. A parallel beam of light falls perpendicular on the plane flat surface A. Referring to the diagram, D is the width of a side and R is the radius of the inner semicircle. Find the maximum ratio of small d by capital R so that the light entering the glass through the surface A emerges from the glass surface B. Now first of all, understand this diagram. If I draw a large scale diagram of the same part, there are two rays which I will consider. Okay, the first ray which passes from the very left hand side of the surface, it gets reflected from this part, okay, and then it emerges from the other side. Okay, and if I consider this ray, okay, over here, this is the ray I will consider. Okay, the ray on the extreme left hand side. Okay, one ray is on the extreme right hand side and one ray is on the extreme left hand side. I will take the radius as capital R. Okay, if I draw an angle over here, that is this angle over here is equal to theta. Okay, this angle over here is equal to theta. Okay, so now whenever I draw this line, this itself will be the normal. Okay, this itself will be the normal, because the line drawn from the center to the circle, will be a normal or the perpendicular to the circle, okay, or the given point. Okay, so if I consider theta and I draw another angle, that is this angle over here, which is over here theta. Okay, which over here should be equal to theta. If I consider this as theta 1 and if I consider this as theta 2. Okay, now over here, the critical angle over here, okay, the critical angle over here will be this theta, that is theta 1. Now the reason for it is if I draw a normal over here, okay, if I draw a normal, the angle between the incident ray and the normal, okay, will be the angle between the incident ray and the normal will be the incident angle, okay, or the angle of incidence. Okay, so over here, if I consider the ray that is on the inside, okay, it's the sine theta will be equal to R. Over here, this distance will be equal to R plus D, because the distance between the inner and the outer semicircle will be equal to R plus D. So sine theta will be equal to over here, it will be equal to R divided by R plus D. Okay, for total internal reflection, the theta should be greater than the critical angle. Okay, the theta should be greater than the critical angle. That is why I am considering the inner surface and not the outer surface. That is, I have considered this angle, that is the theta 1 angle, okay, and not the theta 2 angle. Okay, because if this theta 1 is greater than the critical angle, then obviously theta 2 will be greater than the critical angle. You can clearly see from the diagram that theta 2 will always be greater than theta 1. So the important condition over here is sin theta 1 should be greater than the critical angle, or the theta 1 should be greater than the critical angle, that is sin theta 1 should be greater than certain part. Okay, sin theta should be greater than the certain part. Over here, when I substitute the values over here, I can say that sin R divided by R plus D, okay, sin theta, that is the sin theta, okay, should be greater than this part 1 by mu, that is 1 by sin, or I can directly write this part as 1, it should be greater than sin C. Okay, that is when I substitute the value R divided by R plus D, now sin C is equal to, that is the critical angle, or sin IC will be equal to the critical angle, which will be equal to 1 divided by mu. Okay, which will be over here will be equal to 1 divided by mu. 1 divided by mu over here will be equal to 1.5. So I can say that 1.5 R should be greater than R plus D. So 0.5 R should be greater than D, that is R divided by D should be greater than 1 divided by 0.5. Okay, in the given question it is given that, okay, what should be, okay, the maximum value of the ratio D by R. Okay, the maximum value of the ratio D by R, I can say that when I take a reverse part, it will be equal to capital D divided by R. Okay, when I shift it on the left hand side, should be less than 0.5. Okay, so the maximum value of D by R will be equal to 0.5, but actually the value should be lesser than that in order for the critical angle to take place.